Hey Math 7, Mrs. Ratzberg here. So we are moving on in comparing and scaling, and we are now in lesson 1.2, mixing juice, comparing ratios. This is going to be a 2-day lesson, so if you're listening to this on Tuesday, don't finish the lesson. Keep going to Wednesday and do part of it on Wednesday as well, please. So our focus question is, what strategies can you use to determine which mix is the most orangey? And you're probably thinking, what now? Like, what is that about? And so there's a video that you should be watching in Canvas. It's of me, so no judgment, please. Making orange juice from concentrate, in case you've never seen that before. So make sure you pause this video and go check out that video if you have not seen it already. Okay, so here we see, right here, we see 4 recipes of ways to make orange juice. So one is 2 cups of concentrate to 3 cups of cold water. Mix B is 5 cups of concentrate to 9 cups of cold water. Mix C is 1 cup of concentrate to 2 cups of cold water, and mix D is 3 cups concentrate to 5 cups cold water. And so our task today is to rank the juice mixes from least orangey to most orangey. And you're going to be supporting your answer with pictures, ratios, and other ideas you come up with as a group. And when I say as a group, it's COVID, so as we come up with in your head. So sorry. You must have your order written down along with your reasoning, okay? So go ahead and pause and try and think about how you can do this, and thinking about also some things we talked about yesterday with ratios. We talked about the benefit of part-to-part ratios. We also talked about the benefit of a part-to-whole ratio. So go ahead and consider all of those things and think about whatever would be most orangey would probably have the strongest concentrate or the least amount of water, in a sense, because to dilute the concentrate. Okay, so go ahead and pause now and figure this out. Okay, so we're back. So hopefully you came up with a strategy, and if not, I'm going to share one strategy with you. So I'm going to be making some part-to-whole ratios here. So mix A, I'm going to have, because I want to think about which has the most orangey, so I'm going to focus on concentrate to whole. So that means that I have 2 cups of concentrate over 5 total cups. So I'm going to write 2 concentrate, or 2 CON for con, and then 5 total tot. Mix B has 5 cups of concentrate over a 14 total cups. Mix C has 1 cup of concentrate to 3 total. And then mix D has 3 cups concentrate to 8 total. And then from this point, we need to do a couple of things. We can either estimate to compare these fractions, these part-to-whole fractions, ratios, or we can find the percentage equivalents. And so I'm personally going to do the percentage equivalents, so I'm going to take out my calculator that is not on my iPad. And so I'm going to do 2 divided by 5, and I get 0.4, or let's change the color, 40%. 5 divided by 14 is 0.357, so 35.7%. 1 can over 3 total, I didn't need to type that one, is 33.3 repeating percent. And then 3/8 is 37.5%. So now, what these percentages tell me, they tell me how much concentrate per the total, and it kind of just, I essentially made all common denominators of 100, right? And so which of these mixes has the smallest percentage? And that would be mix C. So I'm going to scroll down. So least orangey to most orangey. I'm going to now write in orange in honor of the orange juice. So our smallest percentage is mix C. So if you like a watered down orange juice, that's probably the one to go with. Then mix B. then mix D, and finally mix A. And again, there are many, many ways of how to figure this out. This is just one way. I've seen students draw pictures. I've seen students find common denominators. I've seen them keep the part-to-part ratio, but have a common number of, well, how much water, like they've gotten a common number for all things water. So there's lots and lots of different options. Okay, so this is the end of the first day. Okay, happy Wednesday. So now we're in part B, and it says assume each camper will get half a cup of the juice. So we're going to use the same recipes as we did from yesterday. Answers question 1 and 2 below for 2 of the 4 recipes. Your teacher will assign you 2 recipes. So if you're watching this online, you get to pick. So how many batches are needed to make juice for 240 campers when we know that each camper will get half a cup of juice? So what we can do first, I'm going to model for mix A, and then I'm going to just give the answers for B, C, and D, okay? So for mix A, we have 2 cups concentrate and then 3 cups cold water. And so that is a total of 5 cups. But we know that each camper gets half a cup of juice. Okay, so if there are 240 campers and each get half a cup of juice, I'm going to 240 times 1/2. That means I need to make a total of 120 cups of juice. So how do I figure that out? Well, I can say 120 cups divided by the 5 cups in one recipe, type that in my calculator, and I get 24 batches that I need to make. So that's mix A. Mix B would be 9 batches. Mix C, 40 batches. And mix D, 15 batches. Okay, so then for part 2, how much concentrate and how much water are needed to make juice for your 240 campers? So go ahead and pause, and based on your 2 mixes that you chose, go ahead and figure that out now. Okay, so I'm going to model again part mix A because it kind of just goes through things nicely. So we know how many batches we need. We need 24 batches. So all we have to do, we have to take our 2 cups of concentrate that we need for 1 batch times 24, and that gets me 48. I'll label this mix A. So that'd be 48 cans concentrate. And then 3 times 24 would be 72 cans of water. Okay, and I'm going to change colors again. Mix B, you would need 45 cups of concentrate, 81 cups water. Mix C, you would need 40 cups concentrate and 80 cups water. You can tell that mix B and mix C are actually they're pretty close, right? Because 81 cups and 80 cups, but then you can tell that mix C would be less because that's 40 cups concentrate to 45. So it's kind of interesting how we can see that as well there. And then mix D, 45 cups concentrate and 75 cups water. And again, you can see like mix B and mix D both have 45 cups of concentrate, but mix B is clearly more diluted because it has 81 cups of water instead of 75 cups of water. So you can kind of see again those connections. Okay, so then for part C, for how much concentrate is needed to make 1 cup of juice, how much water is needed. So this is actually it sounds confusing, but it's actually really simple once you think about it. So when you have 1 cup of juice, you just need to essentially make fractions of part to whole, because then your 2 parts, your 2 fractions of part to whole will add up to 1. So for A, you would have 2/3 cup concentrate, or 2/5, sorry, I read my number wrong. 2/5 cup of concentrate, and then 3/5 cup of water, and then notice how 2/5 plus 3/5 equals 1. For B, it would be 5/14 concentrate, and then 9/14 water. For C, 1/3 concentrate, and then 2/3 water. And then finally, for D, 3/8 concentrate, and then 5/8 water. And those were actually the fractions I used, or the concentrate ones, to figure out my least orangey to most orangey, so that's kind of fun. Okay, so our focus question: what strategies can you use to determine which mix is the most orangey? So there are lots of options, but we're going to kind of talk about a few. So one option would be to find a common denominator. Of part to whole. You could draw a picture. You could find a percentage of your part to whole. You could also use a unit rate of part to part. So meaning, like, if you have 1 thing of water, how much concentrate would you need? And then you could just compare that. Okay, so that's it. So now you have daily practice to be doing. Please let your teacher know if you have any questions, and have a great day, Trojans. Bye-bye.